here it's showing the CPU 20% storage, 7% it's using, and I should have shown the previous command that is in capital script. It's running wrong when it's edit. Hello guys, welcome back to Root and Out. We are continuing with the Rust programming series, and today we are going to explore a bit deeper into threading using Rust. We will be developing an application using a single thread, then convert that to multi-thread and find out what are the pros and cons of having single thread and multi-thread. We'll be exploring both pros and cons of single thread and multi-thread. And basically, if you're asking me what a thread is actually, this is a formal definition I can give you. It's built on standard libraries thread module, and which abstracts over the underlying operating system's threading APIs. That means when you create thread in Rust API using Rust, using the standard module package available, it will call the corresponding thread API behind the scene based on the operating system. As an example, in Windows it calls create thread API, and in Linux it calls the pthread create API. There are some difference both operating systems behind the scene how they make threading space for the application. As an example, in Windows the default size as per the documentation is 1 MB for the thread, but for Linux by default it is 8 MB, but you can change that using the ulimit command, and you can see what the limit is using the ulimit -s command. At the same time you can set using the ulimit itself, but in using Rust thread standard API you can completely control how much stack size you want for a thread. So let's go to the code directly. Today I did write the code already because I don't want to waste the time for inline coding. That actually saves a lot of time while recording the video. So let's go to the code, and this is going to be a single thread application. First, the logic is very simple. We accept two parameters from the command line. The first one is a string, that is an IP, the target to scan, and second one is the port range. Port range, we are just taking it as in the format of a hyphen in between the ports. Just take it as a very simple application. Don't let more confused on this basic functionality. We are just taking command line parameters and converting and just splitting up the ports and just making it's right for us to use it. If you have any doubt on what port scanning is, actually it's one of the processes that we do normally in security assessments to find out open ports on a target machine. So open ports will help us to identify related services and other stuff. But for this scan, we just developed a very basic scan. It's not going to do any packet crafting or a packet analysis behind the scene. Just using a TCP stream connect to the port with a timeout and just identify whether the port is open or not. In Rust, we can make use of the TCP stream package. In that, there's a function called connect timeout that accepts the address, the target address to get connected, and you can set up the time duration as a timeout. So here, after doing this one, the function is returning an is okay. This will return a boolean function. It's return a boolean value that will determine whether the port is open or not. If it's true, that means the port is open. If it's false, that means the port is closed. And here there are a couple of things we just notice. Here we are converting a normal string and a port unsigned integer 16-bit to this format. First target colon port, then we are converting that to a SOC address. We are passing that to a SOC address because that connect timeout accepts a reference to the SOC address. So that's the reason we are passing that to SOC address. It's a very basic thing. Like if you know the basics errors that we were doing in the other videos, it will be easy for you to follow the basic stuff of passing and converting, those kind of stuffs, including the reference strings, everything. We already explained that in previous videos. So if you are seeing this first time and if you are not following this one, please refer the previous videos. It will be easy for you to follow. So come back to this one. We are just doing the basic validations. If any of this passing is failing, we are just printing a message to the console that we are not handling the error properly here. There's a better way of handling errors. I will explain that with more projects while ongoing, how to handle exceptions and errors in Rust. So for this one, we are just concentrating on the threading and single thread and multi-thread applications. So here what we doing is we are just going through the port range from the beginning to the end. Then we call this method, and if the port is open, it will be easy. I mean, it will just print out the port is open. If it is closed, that means this is returning false. Then just prints the port is closed. That's it. So I'll show you two different scenarios here. One machine that is not behind any firewall, and the other one is behind a firewall. I mean, it's not actual firewall, but the Windows firewall. I will be targeting two machines for the demo. For the single thread application, one is a Linux machine that is completely a vulnerable machine, and it has an IP of this one 192.168.188. So I'm just going to do that here. Just let me build the application first, and I'm already here. So let us run it. Port scan. We had to move to the debug folder. Then we may have check it. Port scanner is there. Port scanner. Okay, I'm going to do my IP. So I forgot the IP I mentioned here is 188, and okay, here I created one just a basic it's a command actually. Just added that to a shell script file to run it every time when I try to do the scanning. Here I'm just scanning my Linux machine, and I'm trying to run the top command to find out how much memory and CPU usage it has. Inside the script actually is just the name of the application that I'm running on the left side, and see, you can see it's really faster. Why? Because it's not behind any firewall. It can see within 25 seconds it finished. And if you see, you could if I avoided the close port message, it would be easy to find out what are the ports open. You can see some ports shows it's open. That means it was, I mean, this machine was able to connect to that port, and if I there's the TCP connection was successful to that specific port. There were a couple of ports open on that machine, but if you see that it finished within 25 seconds. If you try the same thing, the good thing about this one single application is it didn't show any high resource usages on CPU or memory while we were doing the single thread application, and it was faster when there were no firewalls in between the source and target. But for I have my Windows machine as a target, and that IP of that machine is 120, and it has the by default firewall enabled. And if I try that here, and yeah, let me try it here, you'll feel the difference between these two. The CPU time and memory is not showing the same as the previous one. The target doesn't make any difference on the CPU or memory, but you can see the slowness that the scanner is taking. Why? Because there's a firewall, Windows firewall, that's blocking to get into the machine directly, not like the machine without firewall. So if I continue this one, it will take some time to finish it, because you can see it moves very slowly here. So here comes the usage of multi-threading. Since this port, everything is running inside a same loop, we are just calling a function. So everything is in a single the main thread. So it needs time to finish it. So every if you can, I just put the minimum, very minimal timeout for this one, just to make it to work in a way that don't wait for too much time. Because if we give more time, if it's so it may try to wait till that timeout. So if it's more, that means it may take more time to finish it. So that's a problem when we have single thread application, especially kind of scenarios where you have to develop your own port scanners. I mean, it's very rare, in fact, in real life, but just for learning, you can do that by yourself. And if it is helpful in different ways, like if some tools, some dependency tool is blocking based on the signatures of some famous port scanning packets, you can make use of your own port scanners. So now we are going to convert this to multi-thread application, and let's see how this works. So I'm going to comment out this part here. Yeah, I think, yeah, just keep the loop, and we go for multi-thread application. We have to we are going to make use of the thread. Oh, it was actually a warning, I didn't remove this, but yeah, just warning was okay for this one. We are going to make use of the thread standard API in Rust to create threads and try to convert the same application to multi-thread. First, the multi-thread we are trying to use is the thread without setting a proper, thread stack. As I said, if you check here in Linux, where's my, yeah, here, if I check ulimit hyphen, as you can see, it's 8.92. That means Linux is giving us 8 MB. I'm working on an Arch Linux, so it's that's updated version, and it gives me 8 MB for the default thread stack. So if so I'm not going to change the first for the first test. I'm going to take this copy this code. I will explain this code, and I'm going to run this here. Oops. What's going to change here is, if you see the change, you can see here we are creating a thread using the thread spawn, and there's a move word here, keyword here. Why? And if you already know the way how REST ownership works, it will be easy for you to understand. For every thread, when you're using thread, and if you plan to use variables inside the thread, you have to move your okay, this is an extra one. Yeah, you have to use a move keyword, because you have to give ownership of any variable that is going to be used inside the thread should be owned by the thread. You can't give a reference that is declared outside and just giving a reference inside the thread. It won't be allowed in Rust. But there's another way that you can create arc references, atomic reference count, that I will explain later. But just imagine for this multi-thread application, we are just going to use of the basic stuff. The thing that you need to keep in mind is any variable that you're going to use inside the thread should be owned by the thread. It shouldn't go outside. The ownership will not be valid after the thread. So that's the main thing you have to create. For that same reason, it will be expensive in terms of memory. Why? Because just imagine I'm creating previously I was just passing the target that was I accepted from the command line, but here I have to create a copy of the target as a string every time before spawning the thread. Why? Because the thread needs the ownership of that. It doesn't accept if I So imagine if I'm going to pass the same original target reference to this thread, it will create a ownership error. Why? Because I'm not allowed to pass the original value. Here what I'm doing is I'm creating another string that is exclusive here inside the loop, and passing and giving full ownership of that to the thread itself, so it won't create issues. There's nothing more we are doing here. We are just calling the spawn method and using the move keyword. We are using the closure, that inside the closure we are just doing the same action that we did before when we were doing the single thread application. Let me see how is there any compilation error on this one. First we format it, and let me see. And yeah, one more thing you have to do is you have to collect the handles, and join is very important. We are collecting the handles here because every thread is creating a handle, so we have to collect the handle, and you have to call the handle.join method. Why? Because if you are not calling the join method, there is no specific usage of this one. We have to block the main thread and let the main thread wait till all these newly created threads finished. Otherwise it will be messy, you can't control the behavior. So you should be collecting all the handles to the threads that we created, and I'm collecting that to mutable vector here, and I'm just pushing the handle there, and I'm iterating that handles and just calling handle.join on every thread that we created inside this method. That is normally the number of ports that we are supplying. So let's see what's the difference, what's the performance difference is giving us. Let me build it. Cargo build. Yeah, it finished. Let us do the same scan again. I'm just going to do my window scan. If you have not already noted, the first window scan when we did, it was very slow. See, I did break it after 117. But if everything works fine here with multi-threading, this will be faster than the other one. And for the single thread, without the firewall, the scanning time it did take was 25 seconds. And for the single thread with firewall, actually I didn't finish it because it was going very slowly. So here we are going to do the same scan multi-thread and see how it works. And I didn't put a watch command here, otherwise it shouldn't. Oh no. Let me run this here first. And you can see it going faster compared to the previous single thread scan. And I'm not sure, did I make any mistake here? Yeah, it's not showing any. Yeah, let me see. If you see, you can see that the CPU. Yeah, oh, now it stopped. Yeah, the CPU and memory increased a bit, and yeah, now it is finished. So I mean, it didn't create much effect, but see, in a firewall state scenario, within 24 seconds it finished ports that was from 80 to 10,000. But if you do the same scan in a firewall state testing scenario, it would be definitely maybe 10 times higher than this one. But if you can see, this one is not scanned it's not as we expected. Like, even though we call the join method, the thread created and the thread handle, it was not in an order that we expected. So this is another way of this is one of the ways of converting a single thread to multi-thread application. So the next thing I'm going to show you is how to make use of the same using setting up the stack. So the difference in that one is here we were using the operating systems by default stack size, that is in Linux is normally is 8 MB as per the documentation, but in Windows is 1 MB. That's the difference. So here, if you want to convert this to the stack size, to set up a stack size, this is the syntax for that one. If you check the syntax, it's easy, but I'm lazy to type it here. So this is a way to create. You can create the builder option and call the new method. In the new, we can set up a name for your thread, and you can set up the stack size. After that, actually, you have to call the spawn method here. So, and one more thing you have to do is, previously, the handle was, it won't return the handle directly. It normally returns a result type. So you have to unwrap to get the handle and push the handles to this one. The difference in this one, I'm not sure if this is going to show us the same stuff. Let me copy this command, and oh no, actually this was an error, in fact. Let me do this command directly here. So now we have set up a stack size of 64 into 124. That is, if it's 124 and 124, it's going to be 1 MB. So I'm just very limiting to very minimal, just 64 KB. So let us try this. And is any error showing? No. Okay, let me build it. It has no errors. So let us try the same scan with the stack limit. And see, here it's showing the CPU is 20%, memory is 7%, it is increasing, and I should have shown, and the previous command, I think something happened on the script, something wrong went to the script. I did put the echo command wrongly. So now you can see the 22% of CPU and memory was about 20%, but it was faster. See, it didn't make much difference. The previous one was, I think, 24 or 24 point something. Now it's 26.12. It may be because I'm not sure why, because normally the stack size limit doesn't affect the performance of this one, but it definitely affects the CPU usage and memory. If the range is more higher, definitely if you're trying to scan the 65,536 ports, then it will be, the memory and CPU usage will be more higher. So that's a way thread works, and this is very minimal and application to check the threading and capability of Linux and Rust. And yeah, this is about for this video. Now we checked the single thread and multi-thread applications with and without setting stack limit, and just changing the difference between when the target is behind the firewall and behind the firewall, when behind the firewall and not behind the firewall. So that's it for this video. On next video, we do the same. We try to explore more on async programming using Tokyo, plus the difference of moving this target string. Instead of creating this one like this, There's another way of Rust allows us to do is using the arc. Arc means atomic reference count. So we will check how much performance we can increase or how much memory we can save using that. That we will explore in another video. And this is the end of this one for threading. See you soon with other video. I'll try to make videos more frequently because I was really busy with other stuff. That's why the reason I didn't make it. But I'm just spending more time on Rust nowadays, so definitely I will come up with more videos, more interesting security stuff, security tool development with Rust. So stay tuned, and if you are happy on this video, just share it, like it, and if you are really interested in Rust, just stay tuned and subscribe. Thank you.